Got our victim chucked up in the lathe. I thought I might just do the skim cut, get this back to normal on this on the outside diameter first before I throw it into the milling machine to do the rest of it. So we'll just check our speed. Now we've got our little surface speed come tachometer. Looking at about 439. So we've got our little fudge factor on here inbuilt, 2.448. That's how inbuilt it is. I've written it on the side of it in case I ever forget. So we had 439 divided by 2.448. Okay, 179 surface feet per minute. So she's running a bit fast. So let's drop it down to the next speed. If I can do it one-handed. Ugh, that was a bit nasty. Right. Let's check again. So we've got about 252. Well, we can tell already that's going to be close. 252 divided by 2.488. There we are. 101 surface feet a minute. Right on the money. So, not a bad little device to have. You know, you can buy these things, no doubt, set up for it. But as your diameter changes with bigger and smaller bars, you need to increase or decrease your RPM. Sometimes you think you're in the ballpark, you're not even close. So, not a bad little item. So I'm using interrupted cut, high-speed steel, supposed to be tougher, and not get so upset over it. Once I get it nice, just about all the way down, I'll see what finish it's leaving. I'm not expecting a good one. Then I'll throw in my favourite tool holder and insert. Gives a beautiful finish, so we might use that finish off with. But being interrupted cut, it may not like it, so it might be sayonara to the corner of a insert. Okay, so I've got it pretty close now. Just got to do another final little cut here, and I've pulled out my little baby and put a new edge, turn the insert around. So we'll feed this along here and hopefully end up with a nice finish. So we'll either win it or bin it. nice. Take that into the milling machine now and fix up the rest of it. Just take enough to clean it up. It's obviously not sitting in there perfectly the same as it was when I did it. See what that looks like. Right, that'll do. Next is the slot. Just going to touch off on this side and see if I can sneak along through here past that little blob of weld. If I can, then I can just work on easing back this way. Okay, so let's see if I can traverse along. Nibbling at something. Help if I go to some RPM, still got more to go. Okay. So I have been able to sneak through. So we'll come back. And not that far. Actually, we'll go through that way. So we're not climb cutting. See what that's like. So I've skimmed back pretty much as far as I needed to. Now I've made a little decision here that the original tool steel that I was going to use, I think is a little bit anemic. So I'm using 3/8. Now I don't have any 3/8 on me, but my son is getting some from work. I'm on annual leave at the moment, or vacation time. So I'm spending lots of vacation time in the shed, having a lovely time. So what have we got here? Does that show up? Possibly, possibly not. Cutter in there now is 0.3165, which is 8mm metric. 3/8 tool steel should be 0.375. Difference is 58.5 thou. So per side, off centre, we need to go 0.2925. So we'll blast this down through the middle, which shouldn't touch, pretty sure it won't, and then we'll go 29 thou either side, and that should now give us a slot in there for 3/8. And then subsequently also going to make sure the depth is the same, around about, what, 0.375 deep. I think I might already be at that. Because we're already downwind, this side is going to be cutting conventional, so let's move it out. We'll move the table in. Our 0.29, 29 thou. Behaves differently where it's been welded, definitely cuts different. Change the structure of the material. I have now effectively repaired our broken off tap. I've upgraded our smaller 5/16 tool steel. Maybe if I know where it's gone. Anyway, oh yeah, there he is there. So I've gone from that fella to 3/8, gone a bit more manly. Out of interest, these are not symmetrical. Won't quite fit in that way. Perfect that way. I think I might have a situation developing here. Well, it's developed, which is, I think it's become work hardened. This is the section here where I've re-welded, cut the piece out for the broken tap and welded it back in. Now it did leave behind probably the slither like that didn't get cut out. Now that may have been, in hindsight, a bad idea. I should have maybe rebuilt the whole corner. The reason being is now the milling cutter to put the counter bore down for the cap head screw only gone so far down, and it's refusing to go any further without really swinging on it. I mean, and when I say swinging on it, I mean body swinging on it. So that's not always a good idea. So I'm going to try freshly sharpened smaller drill, see if I can drill a hole through, and then maybe the clearance hole for the tap, well, not clearance, but the tap, drilling tap hole. If this doesn't work, I'm going to have to get some cobalt drills, which I don't have with me, to continue forward. So if you pray to any deities, pray now. Not using a lot of speed, because if something's really hard, it's better off to use some bit of pressure and not too fast. So I'm not expecting good things here. Oh, starting to... Oh, rightio, maybe the end mill just gave up, he just ran out of puff. It's a bit of oil on the situation. And that was a freshly sharpened drill bit, thanks to Drill Doctor. Might be lucky yet. Okay, that drilled that right enough. Okay, now I'm going to... What do I do? Okay, I'm going to go with the same diameter drill that I used for the other two holes before I broke the tap off. I'm hoping this time it's because it's been filled up with mild steel, be easy to tap. So it is a little bit bigger than the standard tapping drill. So it's a number 4 drill, 5 1/4, so it's 1/4 of a mil bigger than the normal tapping size for a 6 mil by 1 thread. And if this starts off being nasty to tap, then I'll just run a bigger drill through it. So I'm going to even slower. That drill's given up already. So it is hard. So on for Mr. Drill Doctor. These are not a quality drill bit either, by the way. It was a big set of number and letter drills. Let's try sharpening it again. I had still some of the old edge left on it. Right, just going to tap brand new, high speed tap. Not envisaging any problems, but you never know. this point it is going through like butter. I mean, the other tap that I broke had done a bit of work, but not hundreds of holes. Might have done 20. So that's in there. Let's run the bottom through there just in case it wasn't fully threaded. Don't you love neighbours that have dogs that bark all day? That dog in particular is not too bad, but don't worry, others make up for it. I think we're gonna have not needed, no, we didn't need the bottom. Okay, so apart from the cap head clearance or deceit, we're pretty good back on this machining side of things, recovered from our broken tap. So if Muhammad won't come to the mountain will come to Muhammad. So what I've done is I've pulled off the milling vise and I've put it onto my drill press and successfully was able to drill a little bit further in on a couple of resharpens, and so that's pretty much finished the milling work. It's pretty bad when you've got to put it into a drill press to drill a hole. This thing here, mate, I'll tell you what, mill drill, mill part, yep, drill, absolutely not. What a piece of crap. Incurs chatter like you wouldn't believe. When you're pulling on the quill, it feels like you are pressing up against a piece of rubber, and of course when the material fights back, all it does is chatter. So yeah, piece of junk. I'll put the fly cutter arbor back in, into the lathe chuck. Now I've just got to machine this down to 0.78 or 787 thou and 4/10 if I'm good enough. It doesn't really have to be that accurate, but might as well aim for it. Yeah, let's do that. Breaking it, so we just have to go wherever we go. Okay, so I've changed the inserts, well not the insert, the tool holder insert, completely different design. Didn't like the way the other one was peeling off all this fluffy, but thick fluffy stuff was catching on everything. This one's at least shooting out long spirals, but at least I can sort of avoid them and they're not getting tangled up in anything. So that's certainly a difference between mould steel. I could make the mould steel chip break without going silly. So anyway, that's the way it is. Okay, we're starting to get closer to our goal now. What have we got here? 814 thousandths and a bit. We need 787. Uh, 775, 85, 790. So 3,000 off. Let's do that one. This will be the last one. $592 divided by 2.448, so that's 240 feet, surface feet a minute. Not as fast as you think. It's doing 1100, what did we say on our little table, 1100 RPM. Right, how are we for size? Right, 775, 85. So I'm a smidgen under. But that's okay because the arbor can go down to 19 and 18. I do tend to overshoot a little bit on stuff that I do. if I'm not careful. .98, so it's only 0.02 of a millimetre undersize. So let's put a chamfer on the end of this. Make sure our collet goes on there. Yep. Tighten up. Yep. Now it might be nice if we do a bit of a taper sort of thing in there instead of it looking like that. Started off with a steep angle because I can always open it up, and if you start off too open you can't undo it. Get off there. Okay, so we'll just go a bit more, have a look at it. Yeah, I think that'll do. Let's not get over too carried away. What we might do is bring this out a little bit and file it. Give it a bit of a round surface there. Okay, so we've reached the completion of the fly cutter. She fought me all the way. Broken tap, work hardened hole. Anyway, we've got there in the end. Now I just need to sharpen the bit up and cut some flies.